Let's go. Consider the following problem. The radius of the base of the cylinder is decreasing at a rate of 9 millimeters per hour. Okay, so r of t prime is equal to 9. And the height, negative 9. And h of t prime is equal to 2. At a certain instant, the base radius is, so r equals 8, and h equals 3. What is the surface area? The surface area equation, does it have it? No. So let's see, h prime of t is 2. R prime of t is negative 9. And s of t, what is s of t? Not given. I suppose we could find it out, but that had a pi in it. The base of a triangle is decreasing. Okay, so base of a triangle, base prime of t is equal to 13. Base. And the height of t is increasing at a rate of 6. B equals 5, and h equals 1. What is the rate of change of the area of the triangle at the instant? Okay, so the formula is equal to base height over 2, and if we do the derivative of that, we can get what is that? Does that work? I think we can just separate this and get b over 2 plus h over 2. And it has to be times. If b times this equals h times this. So I'll just do the base rule. So b times h is b dh plus h db. And so if we do the derivative, we get low. So 2b dh plus h db. Low d high minus high. And the derivative of low is 0, so minus 0. All over low, that gets us 4. 2 and 4 cancel out. We got all this over 2. So base is 5 times the derivative, 6, plus 1 times derivative of negative 13. So we get 30 minus 13, which is over 2. Minus 13 divided by 2. So 17 over 2, 8.5. Yeah. A 29-meter ladder is flying down a vertical wall at the distance. So the distance between the top of the ladder and the ground is decreasing. Okay, so we have our triangle. It's a 29 meter long hypotenuse, and it's sliding down the vertical wall between vertical walls. The distance from ladder to ground is decreasing at 7 meters. So dh dt dh dt equals 7. At a certain instant, the bottom of the ladder is 21 meters from the wall. So the bottom is 21. What is the rate of change between the bottom of the ladder and the top of the ladder? The bottom ladder is it divided by between the bottom of the ladder and the wall. So how's the 21 changing? Okay, so what does this change? Okay, I see what it's saying. So if we get Pythagorean theorem to do 29 squared minus 21 squared equals 20, I think. 420. So that is 20. So that gets us this. Now it has a rate of change of -7. So that rate of change is actually increasing. If we have the formula c squared is equal to a squared plus b squared, we can say 2c, then rate of change of c, so dc over dt, is equal to 2a dA over dt plus 2b dv over dt, which gets us the rate of change of 29 is 0. To get 0 is equal to, is that right? I think that's right. Yeah. Is equal to 2 times 20 times -7 plus 2, and then h is 21, and dh is what we're finding out of x. So we can divide this, get the 2's cancel out. We get, let's see, 20 times 7 is 140. It's equal to 21x. So 140 divided by 21 is 6.6 repeating. 20 divided by 3 is also 6.6 repeating. I think it's 6.6 repeating, so that's 20 divided by 3. Yay! The radius of the base of a cylinder is increasing at a rate. The radius r prime of t is equal to 1 meter per hour. And our height, so h prime of t, is equal to -4. Okay, so that's cool. R prime of t is equal to +1. H of t is equal to -4. Cool. At a certain instant t of 0, the base of the radius equals 5 and h equals 8. What is the rate of change of the volume of the cylinder at that instant? So volume is equal to pi r squared h, volume. So volume prime is going to be 2 pi r h dr dt plus pi r squared h prime of t. So if we figure this out, we get v of prime equals 2 pi times 5 times 8, and then dr dt is 1 plus pi 5 squared, so that's 25, times -4, and so we get 10 80 pi plus 25 times -4, -100 pi is equal to -20 pi. Oh, I didn't even read the question. Yep, you use this one. Pi r squared pi r squared that sounds right. Does it? This doesn't properly have the derivative. 2 pi. Yep. I just solved the equation. It's negative 25, by the way. The differential function, x and y, are related by the following equation. Also, dx, so dt equals 0.5. dy over dt equals, find dy over dt. Okay, so we have 3x squared minus 2y d over dx minus y dy over dt equals 0. So to find dy, so we put this negative 1 into this equation. With negative 1 times negative 1, that is just 1. So x cubed minus 1 equals 7. We get 8 equals x cubed, x equals 2. So that can put us in our next equation. So y of this equals, so we get d over dt times 3 times 2 squared minus 2, and then y is equal to negative 1. dy over dt equals 0. The d over dx is previously just 0.5, and so we get that. So we get 2 squared times 3 divided by 2. That gets us 6. And then we get minus 6 minus 2 times negative 1. And that gets us negative 2x equals 0. And then we can subtract negative 2 from both sides. So add negative 2. So we get 6 plus 2x is equal to 6. X equals negative 3. Sound right? Negative 3 times negative 2 is equal to positive 6. And that sounds about right. Negative 3. Excuse me. Negative 3. That sounds about right. Yay! The radius of a circle is increasing at a rate of 3. So let's see. dr dt, or let's just do r prime. I like r prime. R prime of x equals 3. At a certain instant, r equals 8. What is the rate of change? So prime of the area of the circle at the instant. So the area is equal to pi r squared. Area prime, area of t prime, is equal to 2 pi r times dr dt. That sounds right. So dr is 3, r is equal to 8. So we get 2 times pi times 8 times 3, which gets us 24. So let's say 8 times 3 times 2. Yeah, 48. 48 pi. That's the rate of change of 48 pi. Sounds right. Three centimeters. Radius is 8. Pi r 2 pi r dr dt. 2, 8, 3, 2, 3, 2. Yeah, sounds right. Hey, last question. Then dinner time. The volume of a cube is increasing at a rate. So V of t equals 18. V equals 8. What's the rate of the surface area of the cube at that instant? Oh, okay. So the volume is equal to x cubed. So if we put x cubed to 8, we get a single side length is equal to 2. Okay, that's important. Single side length equals 2. And then the rate of change of that is, we get 3, 2 squared d over dt. We get 2 squared times 3, we get 12, but we actually have 18. So we need 18 over 12. 18 divided by 12. So 1.5. 1.5. That is equal to v prime. How is x changing? So to get this, we have the surface area. So that is x squared times 6 sides of the cube, times 1.5. That is our rate of change. So you get 4. So 4 times 6 times 1.5. We get 36. And that sounds about right. I think we're right. Yay! Oh, so close. Did we break it? I don't think we did. We only had 7. We have 4 points away. This is 3 points. Okay. Close though. Close to the end.